So dear students, till now we come to know that when two particles are separated by a distance, a gravitational force of attraction comes into play. That means both the mass particle attracts towards each other. This type of interaction is called action at a distance type of interaction. So it is because the two particles interact even though they are separated by a distance, even though they are not in a contact. So the gravitational force of interaction, or this type of interaction between the two particles, can be explained with the help of field. For example, a mass object is placed in a free space. So let us consider this is a mass object, and we are trying to bring another mass object from a distance to the space around the first mass particle. When we bring this mass object, we experience the force of attraction by another mass, that means earlier mass object. So when we bring this object from let us consider from infinity, that means the place where this first object do not attract the second object. So that distance is called infinity here. Otherwise infinity is a very large value. So here we are using because we have considered a particular distance at which the first object do not attract the second object. So we are bringing the object from infinity to the space near the first object. So we can say that the second mass object enter the field of the first object. That means this mass object entered the field of the first, this one's space. So in this space, the second object experience force of attraction by the first object. So this space, the space around the first object is called field. That means in this space the another object experience some type of force, and due to another object the first one also experience force of attraction. So this is the concept of field. So here we are considering mass object, therefore we say gravitational field, and the strength of the field depends upon the force experienced by a unit mass of a object. Unit mass of a object means we can consider 1 gram in CGS unit and 1 kg in SI units, separated by distance r, and it is directed towards the particle producing the field. So from gravitational field we are now able to define what is gravitational potential. Gravitational potential is the amount of work done in bringing a unit mass from infinity to a given point of the field. Since the gravitation potential is represented by the work done, therefore it is a scalar quantity. It is represented by voltage V, just like in electric currents. Gravitation potential at any point in the gravitational field is always negative because the work is done by gravitational field and not against the field in bringing a unit mass from infinity to the given point or position. The gravitational potential energy of mass m at a point is equal to the product of the gravitational potential to that point and mass m. So let us find out the expression of gravitational potential energy. Let us consider one of the object is earth and another is the this object ball. So The mass of the earth is denoted by capital M. The mass of the spherical body is denoted by a small letter m. Let us consider the particle or a body is at a distance r1 from the center of the earth. So if we are interested to lift this particle or body from r1 to the r2 distance like this here. Initially it is at r1 distance from the center of the earth, and if we lift the object by to the r2 distance, then what amount of work to be done to lift the object against the force of gravity? The force acting on the object due to earth or by earth is equal to, we know from universal law of gravitation, it is F equal to capital Z M, uh, capital M, that is mass of earth multiplied by mass of the object, and divided by the square of the separation between these two. So once we have expression of force, we can find out the uh, work done to lift the body from distance r1 to r2 like this. So first of all, we will do what? We will find out the expression for work done for small displacement. For small displacement, let us take it be dr or delta r. So once we have the expression of work done for the dr displacement against force of gravity, we can integrate that expression from giving a limit from r1 to r2. So let us do the derivation. The force acting on point mass m is expressed as the product of gravitational constant, mass of earth, mass of point object, and their separation squared. So here we will first calculate the work done to lift the object or point mass by displacement dr. How much work to be done to displace by dr distance. So the expression for work done is equal to dw is equal to minus f dr. Minus in shows that the direction of force and displacement are opposite to each other. The force of gravity is directed toward the center as we are lifting the object away from the surface of the body. Therefore displacement is in outward direction. Both are in opposite direction. So here it is a negative sign. So, to calculate the work done in lifting the point mass from r1 distance to r2, we have to integrate the expression of dw, small work done from limit r1 to r2. So, putting value of f, we have the expression like this. On solving the expression, we have a rule, integration of 1 by x squared dx is equal to minus x. So using this rule, we have the expression like this. So here negative sign goes out, and on putting the limits we have this. So this is the expression for work done. So gravitational potential energy is expressed in terms of so gravitational potential energy expression is written as like this. So if we take R2 be the infinity, that means the position of point mass is out of the reach of gravitational force of Earth, then we can write R2 tends to infinity. And if R1 has any value r, then the expression for potential energy is written as minus g capital M small m by r. So this is the potential energy associated with mass m on moving distance r on the gravitational field. So we can write the expression as gravitational potential energy is equal to gravitational potential multiplied by r. So gravitational potential is g capital M by any distance r multiplied by mass. So it is the gravitational potential, and gravitational potential energy relation can be written as gravitational potential energy is equal to gm by r multiplied by mass of the object. So from this expression we can say that gravitational potential energy is uh, dependent on mass of the object and separation between the two mass object, that is by r. So as r increases, whole value and magnitude of this ratio decreases, but here it is a minus sign. As decreases, potential energy increases, and where r decreases, this value increase. So with a negative sign, increased value give us less potential energy. So the gravitational potential energy associated with two particles of mass m1 and m2 separated by distance r is expressed as U equal minus gravitational constant product of mass m1 and m2 divided by their separation r. For an isolated system of particles, the total gravitational potential energy is the sum of energies of all possible pairs of their constituent particles. So, we can write the sum of the all potential energies associated with all the pairs of the at mass particles.